These are guided notes number 2 on the metric system basics. And really with the metric system, what you need to understand is just some of the measurements that you're going to be taking throughout the semester and how to make conversions sometimes between those units. So one of the first things that your textbook is going to go into in this chapter is the difference between accuracy and precision. The biggest thing you need here is how to calculate percent error. So this formula that is here is something that you will use throughout the semester in order to calculate your percent error, especially when we're doing labs where your data is really important and I want to make sure that you're getting accurate data. I'm going to look for a pretty low percent error, somewhere less than 10%. So you would take your accepted value. Accepted values will be given to you, and you will use your measured value, which you will calculate in lab. And using those two things, you will actually be able to determine what percent error you have based on this formula. So what you want to remember also is that you're always going to take the absolute value of this top portion of the formula. So what I would say is just do your big number minus your small number, even if it's not in that particular order, so that you have your correct number on top. All right, so in the metric system, in the United States, we don't typically use that, so sometimes we have to remember what we have. We're going to use some basic units like length. We'll measure with a ruler in meters. Typically, we'll be measuring in centimeters, millimeters, or kilometers. We might measure mass, and actually you've already done that in your mass and change lab that you worked on in class on Wednesday, measuring typically in grams when we use an electronic balance. And we will learn how to convert from one of these units to another. We will work with temperature, especially when we get into further units like gases. And what I want you to remember are how to convert between Celsius temperatures, which is what we think about temperature in, and or in Fahrenheit more often than Celsius, but we're going to see Celsius temperatures quite a bit, and then turning that into a Kelvin temperature when you need to. What we will actually do is really only use the 273. So let's say that something is 32 degrees Celsius. How are you going to convert that into a Kelvin temperature? Well, you're just going to add 273 to that. So when you add that all up, you would get 305 Kelvin. And that will be something that you will need to be able to do quite often as we work our way through, like I said, especially the gas units that we'll work on. Time in seconds, amount of a substance, moles is something we will get to somewhere around unit 4 or 5 when we start talking about just some more units that are used in chemistry that we don't typically use in other things. Physics is really going to deal with luminous intensity and electric current, which we won't cover. So one of the calculations you're going to need to be able to do is a volume calculation. How do you determine the volume of a substance? Volume of a regular solid is going to be the length times the width times the height. And you're typically going to measure length in centimeters, width in centimeters, and height in centimeters. So a common unit for volume would be a centimeter cubed as you multiply those out. And one really important conversion factor for you to remember is that 1 milliliter is equal to 1 centimeter cubed. So sometimes you will see, for instance, that you need, you have 5 centimeters cubed, and I want you to tell me how many kiloliters that is. So you would have to make a conversion to milliliters first, and then convert that to kiloliters. Now, water displacement is what we use for determining the volume of an irregular solid. So let's say we have 7 paper clips, and we want to know the volume of those paper clips. It's hard to measure length, width, and height. So what we would do is use a graduated cylinder, put a determined amount of water in the graduated cylinder, place those paper clips in the cylinder, and the movement of the water is the actual volume. And you've done this if you've gotten in a bathtub before. You've displaced water, and that'll be something that you'll have to do occasionally if we can't measure the volume of something easily. When we talk about energy, again, we'll come back to these sort of things. Energy is the capacity to do work or to produce heat. It's a joule or a calorie. This is something that we will touch on in later units, so it's not something that you absolutely have to have now. Now, we will be learning how to do metric conversions starting today. And those are your guided notes number 3. So what you need to do is to copy down this chart. So we may need to pause this video for a minute or two while you guys copy down this chart. Know the symbols, know the prefix, know the base values. So mega is a capital M. It is a 10 to the 6th power. Kilo, lowercase k. Everything else is lowercase. Micro is only a unit where you would have to remember the symbol that you have here, and that's this symbol for micros, 10 to the negative 6. What you're going to end up having is you have a quiz on this chart, and if you take a look at your calendar, you'll have a quiz on that. I believe it's early next week, so be sure that you're prepared for that. What you need, like I said, to remember is you'll get a chart similar to this. Pieces will be missing. You'll have to fill in the missing information. So filling the missing prefix, the missing symbol, or the missing base value. So when we talk about what the base values are, there's 3 base values: meters, liters, and grams. And so what we will do is we will look at the prefix of a unit. If we know that 1 kilogram, and we go to kilo, well, kilo on the base unit is 10 to the 3rd grams. There's our base unit. If we were saying 1 milliliter, 1 milli, okay, so we go to milli. Milli is 10 to the negative 3rd of the base unit, whatever that base unit is that you had before. 1 megameter, again, same principle. If we look at mega, mega is 10 to the 6th power. So again, we have our 10 to the 6th power here. So the base unit is always going to be some power of 10 that we have to get to. Alright, so what's the only number that we should ever write with a prefix? What I want you to always remember is the only number that you should ever put with a prefix is a 1. Okay, so any unit that has a prefix on it, any of those that are in the chart, the number you put with that is 1. So for instance, 1 kilometer, okay, is equal to 10 to the 3rd of the base unit, meters. Okay. What is the only number that should be with the base? That should be where our power of 10 comes into play. The only number we'll ever put with our base unit is 10 to some power. How do we know what that number is for the power? We have to go back and we have to look at that prefix to determine what that actual power is. Okay, so that finishes up guided notes number 2 for you. What we're going to be working on and moving into next are guided notes 3, learning how to use this information as you go. Basically.